Okay. You go, Chad. I'm on the white screen. Okay. Let me know if and when I'm live. Live. We did it. Excellent. Okay. Hey, everyone. We did it. We made it. We're back for the Monday live show. So for those of you who are wondering what it is that you have stumbled into, this is going to be a 2-hour long questions and answers session where you hit me with your questions and I answer them to the best of my knowledge. And that's it. That's all this is. But if that's what you're into, then I think this will be a good time. Now, go ahead and put any questions that you have into the YouTube chat. And then already I can see Zappan. Zappan is here. So we've got one of the moderators. And so we will go ahead and gather those questions and put them into a database. And then I'll be able to choose questions from that database and hammer through them as quickly and as efficiently as I can. Now, a couple of ground rules. One is I try to give emphasis to the people who've never had a question answered before in the live, in the edited videos. So we do the 2 question shows every week, and I try to give, and we keep track of whose questions got in those shows. And so that way I can, if I see your name and it has a no number beside it, I can try to answer it. I've already hit record and I've already done the color chart. Second thing is keep in mind that I am a journalist, not a scientist. And so I can provide you with the scientific consensus of what people believe. I cannot give you any additional information. I have no opinions. I am not equipped. I am uninformed. I am merely a mouthpiece for the scientific consensus. And if you're here and you're watching this, I hope that you think that that's a good thing. That that the very minimum bar for being able to express personal opinions about scientific theories is to, at the very least, have done an equivalent amount of research to the people who are exposing the different scientific theories, and then espousing the different scientific theories. And at that point, you can participate in sort of which science is the best science, which observations, I guess, which theories best match the observations. Until then, we're just spectators. We get to enjoy the ride and, cheer on the teams. Thirdly, we get a lot of the same questions over and over again. And so I try to sort of mix and match it. And so that way, if I haven't answered your question, it's not that it was a bad question, although it might have been. But mostly it's because we've answered, we've had that question a lot. And so I just want to try and give some balance to what we do. Otherwise people go, oh, that question again, when they're listening to the show. So that's it. We'll try and sort of keep everybody on our toes. Let's proceed. So go ahead, put your questions into the YouTube chat. Zappen's here. Cassie or Casey? You're going to need to tell me the description because I see a lot of your questions. Tell me, is it, so if it's Cassie, put a number 1. If it's Casey, put a number 2. All right, let's begin. William Hallman, what are your thoughts on 3i Atlas and the chances of it being not natural? Right. So in the most recent Space Bites, I was talking about 3i Atlas, and I was saying that, it's a comet. And what's it going to do? It's going to behave like a comet. It will continue to behave like a comet until it leaves the solar system. And then I had a bunch of people in the YouTube comments tell me that I was being ridiculous. How can I know that it's a comet? That is not a very scientific argument to say with 100% certainty that this is nothing other than a comet. And that is absolutely right. That for me to say with absolute certainty that thing is not a comet, that thing is a comet, for me to say with absolute certainty that that thing is a comet is closing off the possibilities that it is not a comet and that it could be something else. Not natural, but like it could be artificial or it could do something really weird. And so there is always a possibility that the thing that you're looking at is not what is most likely. And so this comes down to probabilities. The example is you go out and you buy a lottery ticket, and that there are, your chances of winning the lottery are 1 in 500 million. And so are you going to win the lottery? Probably not. Are you certain to not win the lottery? No, there is a chance that you could win the lottery. But if you were a betting person, you would bet that you're not going to win the lottery. If you're a betting person, you would bet that you're not going to win the lottery because the chances are very low. So that is the sort of situation that we find ourselves in. And that is the same thing to which I'm approaching and which the scientific establishment is approaching Comet 3i Atlas, which is that we have experience with comets. We have seen thousands of them that do comety things. They pass down into the inner solar system. They grow a tail. They have a coma. They contain various volatile chemicals start to spew off of them. You're able to measure their carbon dioxide ratios, their carbon monoxide ratios, their nickel to iron ratios, and a lot of other cyanide amounts and quantities, as well as their water, silicon. Like, you can get a sense for what these things are made of because they are spewing these chemicals into space. And the time in their orbit, or their, the farther away they are from the sun, the less of these chemicals that they are producing. And then as they get closer and closer to the sun, the more of these chemicals they produce because they're getting hotter. And so if you sort of imagine that the outside of the comet is covered in a bunch of different kinds of chemicals, and then each chemical has a point where enough temperature will cause it to sublimate and blast off into space. And that gives you a chance to sort of tell exactly what this comet is mostly made out of. And of course, in addition to us being able to analyze the chemical composition of probably hundreds of these comets that have come from the Oort cloud, we've also had the chance to study many comets that are repeat visitors. So Halley's Comet. And then we have even had a chance to go and do a flyby through a comet tail with the Stardust mission. Was it Swift-Tuttle? Was it Wild? Anyway, Ville 2. And even ESA's Rosetta mission has gone into orbit around a comet, 67P. I won't even try to do it. And so we have plenty of examples of comets. We also know a lot about asteroids. We have examined, again, we know of 1 million asteroids in the solar system. So we have this understanding of the kinds of objects. We understand how orbits work. We understand how movement works. And then we have experience with 3 interstellar objects, Oumuamua, Borisov, and now Comet 3i Atlas. And you can extrapolate this understanding of the motions of objects, both for what we see with the long period comets as they come into the solar system and they follow these very specific orbits. They generate their tails. They generate multiple tails, depending on how far away they are from the sun and what kinds of chemicals are in them. They develop this coma. Borisov did that. Oumuamua was weird, but not like spaceship weird, just didn't come from the solar system weird. And now Atlas is doing its own version of weird. But again, not spaceship weird, just didn't come from the solar system weird. So the ratios of carbon dioxide to other chemicals in its coma are much higher, has a lot more carbon dioxide, and that this carbon dioxide started to sublimate a lot earlier than you normally expect. It started to produce its coma a lot earlier, which means that it has a lot of chemicals that are more easily sublimated when it's farther away from the sun. The ratio of the carbon monoxide is different than what you would expect. And then the ratios of nickel and iron that are mixed in with it. And of course, comets aren't just balls of snow. They are dirty, rocky snowballs where they've got some amount of water, other volatiles mixed in, as well as material that's kind of like soot, carbon compounds, various organic chemicals. They also have silicon chemicals, rocks, and then they also have various metals mixed in with them. And a lot of these metals, like the iron and nickel and other metals, are often connected with organic molecules or with carbon molecules on the outside of these comets. And so this is why people are talking about the nickel to iron ratio, is that at a certain point, when the comet heats up, these chemicals sublimate, and you are able to measure the presence of iron or nickel in the coma around the comet. And so Comet 3i Atlas, interstellar object 3i Atlas, is doing all of these things. It is following with mathematical precision the hyperbolic orbit that it has been following all the way in so far. We've been seeing it since July 1st, and now here we are, middle of October, and it is still following with mathematical precision the laws of gravity, Newtonian gravity, as it is falling towards the sun. It's going to reach its perihelion at the end of October. And so now you've got to say, is it a spaceship or is it a comet? And the proper scientific way to say that is, there is no way to know with 100% certainty whether it is a spaceship or whether it is a comet. But you can analyze all of the evidence that has been gathered so far about this, its movement, the kinds of chemicals, the way it's produced a coma, the way it's produced a tail, and say that is behaving very comet-like and is very similar to the other objects that we have seen, or it is a spaceship. But the thing is that we have no examples of alien spaceships to compare it to. Do alien spaceships have this ratio of nickel versus that ratio of titanium versus what kinds of signals do alien spaceships tend to send to us? We don't know. And so far, we're not getting any signals from it. The ratios of the various chemicals are, in some cases, a little out of whack, but that's what you might expect from an object that came from another solar system. So, and again, I always say, I'm just a journalist. I'm not a scientist. And so I read the papers. I read the science papers that are coming out every day. There are about 100 science papers that have come out on Comet 3i Atlas. 98 of them are talking about, it has a coma, here's the pictures that we took, here's the movement, what star systems did it pass in its history, where in the Milky Way did it probably originate from, what is the future, what are our chances to be able to take images of it when it goes past Mars, when it goes past Jupiter, and so on. And then there's like one paper that says, it could be an alien spaceship. And it goes through a whole bunch of stuff that says, here's why it's weird. And then in the last chapter, it goes, and we can't rule out that it's an alien spaceship, right? But you can say that about anything. I can't rule out that my car is an alien spaceship. I can't rule out that my house is an alien spaceship. I can't rule out that YouTube is an alien spaceship, right? Because when it can do anything, right? What can the alien spaceship that looks like my car pretend to be like a car? Yes. Can I plug in the alien spaceship to recharge its battery? Yes. Right? Like, can I put tires on the alien? Of course you can. Right? And then all kinds of other things. Like when the explanation can do anything, then it actually offers no predictive powers at all. It is no explanation. And so this is where we're at. And so when you look at the people who are saying that this is a spaceship, again, there's a chance. We can't rule it out. We must not be closed-minded. But then you have to say, what is the preponderance of the evidence? What is the evidence that you are using to make the compelling case that this is a spaceship? And so far, the case that people are making kind of sounds made up in many cases, when they're talking about stuff, or they are taking something that has been legitimately discovered and then are extrapolating it to where it shouldn't go, right? Why does it produce a tail? Well, the alien spaceship could be having some kind of tail to cloak itself so that it makes people think that it's a comet, so it can take close-up pictures. Or when it goes behind the sun, then it can change its trajectory and do something really sneaky and crafty, right? So that's, again, we're going to have this conversation every single time there's an interstellar object until we're bored of it, until we're at our 1,000th interstellar object. And they've all done exactly what interstellar objects have all done. And we've learned a tremendous amount about other star systems. And none have exhibited an alien spaceship behavior. And yet, as I mentioned in another previous video, the most likely way for an advanced civilization to spread from star to star is to send robotic spacecraft from star to star, that they go into these stars, they go to the asteroid belt, they build more copies of themselves, they go to the star systems. Like, that is, when you sort of do the thought experiment of how that might go down, that makes a ton of sense. So, so I think I am ready to be wrong. I can't wait to be wrong. But if I was just going to go and place my bets, place my odds, it's a comet. An interstellar comet. Isn't that wonderful enough? What is feel free? Okay. Sean Young, are there any photos of 3i Atlas? Yes. There have been a whole bunch of photos of 3i Atlas taken over the last couple of months. I'd say probably 10 observatories have gotten into the fun. Most recently, the Perseverance rover was looking up into the sky, and a sort of citizen scientist was able to stack up a bunch of images from Perseverance and show an image of the comet in the sky. Now, the best image would have come from the Mars Reconnaissance Orbiter, but then the government shutdown happened, and I don't know if they were able, if they were allowed to go into work and to schedule taking the pictures. But the European Space Agency has the Mars Express spacecraft, and they're able to take pictures. So I wouldn't be surprised if in the next couple of weeks we're going to see some pictures from at least Mars Express, hopefully from the Mars Reconnaissance Orbiter. Oh, what a tragedy if, because of the shutdown, we weren't able to get pictures when it made its closest approach. But then we're going to get some other chances when it goes past Jupiter, although Juno might have been shut down. Wah, wah. Okay, so it's Cassie. Okay. Or is it Casey? Oh no. Now I don't know what it said. Daniel Verburn. Fraser, do you have a favorite space documentary or series? The 1999 BBC series The Planets arrived at just the right time for me. The classic one is Cosmos with Carl Sagan. And I went back and rewatched Cosmos about, how long ago was this? 10 years ago, when Twitch was live streaming Cosmos. And so I actually did a live watchathon with a bunch of people. So we watched each hour of the show, and then I had very special guests on, and who were kind of related to the episode of Cosmos, and we did the sort of like a critique, a I don't know, a voiceover on what we were watching. And it kind of holds up and kind of doesn't. I think we were also starved for content back when Cosmos came out. And so someone was like talking about space. It was incredible. I would say although it's not space, but I would say The Day the Universe Changed is probably my like favorite sort of documentary series, although that's more about sort of human history than it is about space exploration. But I would say that there's been a bunch of Nova documentaries about space exploration, specific missions, things like that I liked the best. But I can't really think of just mind-blowing, amazing space documentaries. Cosmos is the only one that kind of comes to mind. And I know there's a bunch of other ones. There's, the one that Morgan Freeman was the voice of, and there's the Our Universe. I forget the one. Paul Sutter's been a guest on it, and Pamela's been a guest on it. But yeah, I don't think it's been great for space documentaries. There we go. It's Casey. Okay. Matthew Bronson, how do stars get so big? Once fusion starts and there's enough outflow pressure to overcome gravity, it seems that new material could not be pulled in because the outward pressure is too great. So that's not the limit on the size of stars. That the stars theoretically could just gather more and more material forever. They could just get bigger and bigger and bigger, and then that would put more sort of temperature and pressure at their core, and they would live shorter lives, and then they would run through all of their material in their cores, and then they would implode and then explode as supernova, and then form a black hole. The thing that is the limit to the size of a star is actually how hot the star becomes. So a star like our sun is like 5,000, about 6,000 Kelvin on its surface, 5,700 Kelvin on its surface. While the hottest stars can be millions of Kelvin on their surface. And so there's this incredible high energy radiation coming off of these stars. And so as new material is trying to fall down into the star, it heats up and you get all of this radiation that's pushing it back out. And you get this limit of about 100 times the mass of the sun, that stars can't get bigger than about 100 times the mass of the sun because of the outward heat and light pressure that's coming off of the star. And that's a limit. And so when we see stars that are bigger than that, then we assume that something weird happened, like maybe two stars collided to make a star that is 165 times the mass of the sun. And the same situation happens for black holes. But for black holes, it's the rate that it's the rate that they can grow. So a black hole can only consume so much material, and then it gets this accretion disk around the black hole, and then the accretion disk puts out a lot of radiation, and the radiation stops new material from being able to fall in, and that sets a limit on the speed that a black hole can grow. It's called the Eddington limit. And yet, weirdly, astronomers have found examples of black holes that have beaten the Eddington limit by several factors, which requires an explanation. It's kind of a mystery. Was it Connections or Day the Universe Changed, where James Burke is standing and talking about the launch of the Apollo astronauts, and then the rocket takes off? That's crazy. That's like the best timed documentary ever. Alexandre L'Esperance. If Earth is our cradle, must we humans conquer other planets to live on? Well, humanity is doomed by the sun, that at some point between 500 million and a billion years, 1.5 billion years, somewhere around there, the sun will have heated up to the point that the Earth's oceans will boil. The radiation pressure in the solar wind from the sun will blow away the hydrogen and render life on the surface of the Earth impossible. And then, 4 billion years after that, the sun will blow it up as a red giant, maybe consume the Earth, and then turn into a white dwarf. So there is a ticking clock. And that, yes, the Earth is our cradle. And if we don't do anything, and although it's a long time, 500 million years, a billion years, it's a very long time, eventually the planet will become inhospitable. And so what do? Right? A civilization has arisen today that has the ability to go to other worlds. And so the question is, should we? Is that a good idea? The first question you have to ask yourself is is there anything on those other worlds? Is there somebody already living there? Are there any indigenous species living on those worlds? Are there bacteria? Are there microscopic life forms, or maybe something even larger? And we should very carefully examine. And if we do find life, we should really consider how we plan to use those worlds, because it might be that the life on those worlds, is the only example that life formed independently from Earth, and we should learn about it instead of just setting up shop and taking over. But what if it turns out that we're alone, that if there is no life in the solar system, there is no life on any other star system, that the entire observable universe is just rocks going around balls of plasma, gas, dust, that's it, ice, and that there is no intelligent life anywhere in the observable universe, maybe even no life at all, then do we have a responsibility to continue just the very concept of life, right? Is the universe made better by life? Are trees better than rocks? I argue that they are. I think that life is special. Life is, if we are alone, then the universe cooked up something pretty special with life here on Earth, and then put it into our hands and said, put this tiny little ember of life into our hands and said, spread this. And then hopefully we will do that we will take life across the universe. And the universe will become this weird, complex, vibrant ecosystem into the future. And if we don't, then life will end with us. Now, obviously, if we find evidence that aliens are out there and they're in the process of doing what I'm talking about, then we're off scot-free. We can just kick back, enjoy, do whatever we want, and know that the aliens are going to take care of the universe, and it's not our responsibility. But yeah, I do think that our future does lie in the stars. It's and people always think that I'm so against space exploration or so against going to other worlds, and I'm just not. I just am realistic about the time frames. That's all. Ian Salter, if Planet 9 turns out to be a primordial black hole, will we be able to use it as a gravitational lens? That's an interesting question. So, one really out there theory is that Planet 9 is a primordial black hole left over from the Big Bang. And black holes can be used as gravitational lenses. And normally, the gravitational lens, people always ask me if if it's so far to use the sun as a gravitational lens, why don't we use Jupiter? But the problem is that the actual gravitational lensing of Jupiter is not very good. And so you'd actually have to go dramatically farther away from Jupiter to use it as a lens instead of the sun. That the sun is the best lens that we have access to. But a black hole gives a very tight lens, but it's the event horizon of a black hole that has the mass of a dwarf planet is not very big, right? Like if you turned Earth into a black hole, you would have an event horizon of a centimeter across, right? It would not be a very big black hole. And so you would be able to use it as a gravitational lens, but you're not going to get the kind of gravity that you're hoping for. So you want to use the sun, or you want to use like a real black hole, a stellar mass black hole. Now you're talking. So yes, theoretically, you could use Planet 9 as a gravitational lens, but it wouldn't be a great one. Greg Lance, I always had doubts about the Big Bang and all matter originating from a single point. Why didn't more astronomers previously explore alternatives to the Big Bang prior to Webb's discovery of distant galaxies? So there's a lot going on in that comment that you just said. So I want to kind of dismantle this bit by bit and hopefully then reconstruct your question, or at least sort of your understanding of the situation. So the first thing is that the Big Bang does not say that all of existence came from a single point, a singularity. That is a misnomer. And it's unfortunate that that misnomer is out there because it's stuck. And so now people like you, and even me a little while ago, sort of thought, like, that's really weird, right? Like, how could you have this infinite universe somehow be compacted down into a point that is infinitely small in size? And the way astronomers, like, actually, if you actually talk to cosmologists about this, they say, no, it's not that the actual full infinite universe was in this singularity. It's that the observable universe, the part that you can see, the sphere around you, was once dramatically smaller. Possibly as small as an atom, definitely as small as like a grapefruit, right? But that was just a tiny part of the actual full universe. And so right beside that grapefruit-sized observable universe, moments after the Big Bang, there was another one, and then another one, and in 3 dimensions, as many as you could go, an infinite distance. And so the universe was infinite before the Big Bang happened, and the infinite is still infinite, right? The universe was infinite sort of before the Big Bang happened, and then the universe is still infinite after the Big Bang. It's just that it's becoming less dense over time, right? So there wasn't this all matter originating from a single point, just that everything was a lot more compact, and now it's a lot less compact. Now, why didn't astronomers previously explore alternatives to the Big Bang prior to Webb's discovery of distant galaxies? So Webb didn't discover or see any galaxies that are like farther than what would be predicted by the Big Bang. It has observed galaxies that are surprisingly larger and more mature than what a lot of the sort of mainline theories were predicting. But the sort of full scope of the theories about cosmology, sort of those observations fit within those theories. So nothing has been completely, shockingly discovered. It's just that, if there's a scale, and you're expecting most likely the observations to show up right in the middle of the scale, they're a little this way, that they're bigger than you would think. But wouldn't it be weird if they were like a little smaller than you would think, right? It's all within that scale, but all that scale fits within the current sort of modern cosmological models of the universe. But there are people who have alternative theories about the universe who have been jumping all over these, the new data are coming in, and people are quite excited about this, and people are using this as a chance to promote and push their pet theories. and theories that most people won't take seriously. People, they can't get their theories published in journals, or they have tried and they don't get a lot of traction because they make predictions, or they fail to make predictions, or they make predictions that don't match the observations, and so they have to be discarded. And instead of discarding their theories, they just wait for the next sort of mild controversy in astronomy to jump in and say, actually, our theories are valid, and here's the reason, and blah, 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 right? And you're seeing a lot of this. And that's what you always see. We saw that with the Hubble Space Telescope. We see that with, we're seeing that with the DESI survey. We're seeing that with James Webb. This is the thing that always happens. Like, you can set your watch to it. And yet there are plenty of very legitimate scientists who are proposing all kinds of alternative theories to the early universe, that, although the scientific consensus is about the Big Bang, even inflation and the cosmology and all the kinds of evidence, the lines of evidence, because the lines of evidence are very strong, that the evidence that has been seen so far really supports this idea of the Big Bang. But there are plenty of people who are proposing different versions, whatever, and that, if they fail to make predictions, or people fail to make observations that match, then their theories are just kind of like lost, or they just sort of sink down into history, as opposed to the ones that make interesting predictions and people actually see those things. So this is just part of the cycle of people who, whenever you get a new tool like Webb, you're going to discover things. You're going to uncover new mysteries. That's just how this works. And that they are going to put strain on your existing theories. This is why we have the Hubble tension, the crisis in cosmology, that the expansion rate of the universe at different times is not matching what we'd expected. That's exciting. Not predicted. Still fits within the current models, but maybe new physics need to come to help explain this. And so now scientists are working really hard to try and figure out what those new physics are. So, I'm trying to think, yes, astronomers are constantly challenging, critiquing, attempting to overthrow their existing theories, because the easiest way to disprove a theory is to find a counterexample, right? If I say that it never rains on a Tuesday, and then on one day on a Tuesday it rains, we can now throw that theory out, right? I can't say it never rains on a Tuesday, because one time it rained on a Tuesday. And so that is the process, is that you go through this, you're trying to disprove your theory. And the more your theory resists being disproven, the more you're unable to disprove it, then the more sort of probability that you should give to that theory of being a rough approximation of reality. And then as soon as something better comes along, you switch to that better thing, because that is the rational thing to do. Emily Tarver, what is something that the public doesn't realize about what it takes to report on space news? I think that I want to sort of more generalize your question, which is that it's not necessarily about space news. It's about science news in general, because it's a very tricky field to report on, because, we're all quite experienced with, say, health news, where you read some, you see some TV news where people say, turns out caffeine is bad for you, increases your chance of getting a heart attack. And then a couple of years later, someone says, no, caffeine is good for you. It actually reduces the chances of you having a heart attack. And now you're like, well, what am I supposed to do, right? Am I supposed to drink coffee or not drink coffee? Drink a Coke or not drink a Coke? I don't know what to do. And that's because of all of the fields that are out there, science is the one that is is trying to change its mind, that is trying to constantly update its perspective to match the experiments, to match reality. And that, when you hold a certain belief and then you are updated with new information about reality, you have to change your beliefs to match reality. And that is not a thing that people do. It's not a thing that people are comfortable doing, right? When you think about people's religion, for example, and you say to them, well, what evidence would it take to prove to you that your religion is incorrect? Or some facet of your religion is, that you're interpreting this incorrectly. And they will say like nothing, right? Like I have faith. This thing is true. Right. And yet if you ask a scientist, you say like, what would it take for you to change your perspective on this theory? You'd be like evidence, just some new piece of evidence, that if we found a fossil of a squirrel in the Jurassic period, right? Or in the what was the Cambrian? Yeah. So if you found like a squirrel fossil in the Cambrian explosion, right? Then that would cause you to severely question the way we understand the theory of evolution. That, okay, this is really weird. And so new evidence has come along, and now this shakes my belief in the state of science. And so a lot of the times, and you see this where, for example, people who are arguing about, say, climate science, and somebody will say, well, back in the 1980s, people thought there was going to be global cooling. Therefore, I can't trust anything that you scientists ever say, right? And yet the whole point is like one group of scientists made a study that other scientists were skeptical about. And yet that's used to kind of tarnish the entire field of science, which is ridiculous, right? You can think about lots of analogies where that wouldn't really hold. And so my challenge as a science journalist, and that's sort of like the more general term of what I am, is how do I communicate the new discoveries, the new theories, the observations with the level of uncertainty that is required, right? That's why we have to use all these weasel words. Scientists have found evidence that there might be a new kind of thing with provisional, maybe some agree, others disagree, so on and so forth, right? Like it is this really tricky kind of slippery way that you have to talk about these kinds of discoveries to do them service, to not just say, right, this thing is absolutely sure, right? Because that it might not be sure in the future. And people don't like that kind of uncertainty. And so they get very offended. And yet, science is the thing that has given us so many of the wonders of our modern existence, that when we give in to the uncertainty and we are willing to let our beliefs match the bulk of the evidence, we're actually finally able to make progress in this world. That humanity spent millennia, tens of thousands of years just going with their gut, right? That the water lightning bolts, they're gods throwing bolts at us. Gods are angry. What is a volcano? Gods are angry, right? And you move to this time where we actually have evidence. We build up evidence. We use the scientific method. We figure this stuff out bit by bit, piece by piece, and we change our minds. And I think that being able to communicate to people how it's a good thing to change your mind, to keep an open mind, to be flexible, to wait for new evidence, to adopt it, and hold your beliefs very loosely is a really tricky thing to do. And, for my field, it's relatively easy. You can say astronomers saw a black hole, or astronomers think they saw something that looks like a black hole, took a picture of what they believe is the event horizon of a black hole. Like, it doesn't impact our day-to-day experiences. And so the amount of grief that I get for being a space journalist is very low compared to the amount of grief that the climate reporters get, or the grief that the health reporters get, or nutrition reporters, or any of that kind of stuff. And yet And now it's been very much, it's become a political thing. People are like, right now, some angry person is going to tell me that they're never going to watch my show again because I talk about climate reporting. And which is fine, like this isn't for you. But yeah, I would say that is the challenge. And it is it's like an art form, and it is not a thing that I knew how to do by default and have had to learn over time to be able to kind of walk that fine balance between here's all these cool things that people have found out and think they know, and also here is the uncertainty that we all have to embrace every single day as we want to be able to move forward in our understanding of the world. But in general, it works. So Casey, what is the point of having both Argus and the NBL? Argus stands for the Active Response Gravity Offload System. I don't know the specifics on this. I haven't done any reporting on that. None of business. What are your thoughts on the new moon discovery? Could that affect the numbers used in the search for Planet X? So the new moon is a quasi-moon. This is a example of a small, like a few tens of meters across asteroid that is doing this gravitational dance with the Earth. So like, what effect will this have on search for Planet X? Nothing. No effect. Totally different part of the sky that people are going to be looking for Planet 9. John DeVita, when Andromeda collides with the Milky Way, why is it said that the result will be an elliptical galaxy instead of a spiral one? That the elliptical galaxies, M87 is the best example of this, are the result of many collisions between galaxies that are very similar sized. So when you have a spiral galaxy like the Milky Way and it's being hit by various dwarf galaxies, and we've been hit by probably dozens, and there's probably 100 dwarf galaxies surrounding the Milky Way, but they're very small. Some have just a few hundred stars. Some have a few million stars at the most. They don't cause that much damage to the structure, the spiral structure of the Milky Way. But Andromeda is bigger than the Milky Way, right? It has more mass. And so when those two come together, then the spiral, this nice spiral structure, is just finally destroyed. And so it becomes this buzzing cloud of stars instead of these nice spirals. And all these gravitational interactions between all of these stars continue to mix up and blend up the thing until you get this very egg-shaped galaxy instead of a nice spiral. So it's just whenever you get two galaxies, spirals that are roughly the same size, and then a third, a triangulum is going to hit us as well. Yeah, it just turns into a mess. And that's what an elliptical galaxy is a mess. A hot mess. Meathead 76 Zace. Does food taste differently in no gravity? Yes, it does. So what happens when you are in microgravity or in weightlessness is that you no longer have gravity pulling your body, pulling your juices, your blood, your spinal fluid, your sinus fluid down, your eyeball juice down. And so these fluids will redistribute in your body, and often astronauts get these very puffy faces, and that comes from sort of blood starting to kind of pack in around, and they feel like they have a head cold all the time, and it affects their sense of taste. It makes them very congested, and so things don't taste very good when they're in space. And they compensate by spicing things like crazy. And so they found that astronauts were going through their spice much more quickly because they just couldn't get any flavor out of everything that they were eating. So yeah, it does change what you taste because you feel congested. And you've experienced this, right? You have a head cold, food just tastes like cardboard. And then finally the head cold clears up and now you can taste food again. I know like a lot of people got that with COVID, that you lost your sense of taste when you had COVID. Yeah, eyeball juice. I believe that is the technical term. Robert Shaw, can you explain why there is a huge hexagon storm on Saturn? Partially. That there is you can actually do this experiment if you have like a science center. The one that I had in Vancouver had this. There was one in Seattle that did this as well, where you have this sort of disc that you turn, and inside of it there's sand and some fluid. And when you spin it, you get these weird shapes that are very kind of hexagonal shapes. And so the effect that's happening on Saturn is probably something that's very similar, that you've got rotating storms that are able to go all the way around on Saturn, and the way these cloud decks interact with each other sets up these standing waves that have this interesting hexagonal shape. And I think there's one on Jupiter as well. Like it's a thing that keeps getting repeated. Dave Ibbotson, are there any scientists looking at the stars in the kill radius of Betelgeuse for an SOS message? So I don't know if anybody has actually done a SETI search at Betelgeuse for a message. And the problem is that the explosion from Betelgeuse will move at the speed of light. And so we will know that the explosion has happened, or in fact, the people on a world that is very close to Betelgeuse will know that the explosion has happened the moment the energy from the explosion is washing past their planet. You don't get any notice really. So they won't get any warning. It'll just be, hey, look, there's Betelgeuse. Hey, look, our world's on fire. And we will see the same thing, which is we'll watch that world be on fire, or that world will have already been destroyed by the time we see the light coming from Betelgeuse for the first time. But this kind of leads into something that I want to talk about, which is kind of interesting, which is that when we are trying to receive signals from other civilizations, the problem is that the search space of the universe is gigantic, that there's all of these different radio frequencies that we could be searching at. There's all these places that we could be looking in. There's too many variables. And so we don't know where to look. But astronomers have proposed that bright events that are visible across the entire galaxy, across maybe even the entire universe, are the perfect times to try to signal to each other. So when you think about, say, Betelgeuse, right? Betelgeuse is going to go off, blow up as a supernova. Now, only if you're within 25, 30 light years of Betelgeuse is it really a problem for you. But the sort of the light that's going to come out of the supernova is going to be expanding at the speed of light. And so that can be used as a clock to say, okay, when that light has reached a star that has an advanced civilization on it, that civilization will send a signal towards us. They'll say, they'll send a signal to all of the stars that they think might have life on them, or specifically they know we're here, and so they know they're going to send a signal to us. And so they send a signal the moment they can see Betelgeuse happen, or the moment they can see a specific gamma ray burst happen. They send a signal towards us, and then we can calculate, right? What is the moment when they would have sent us that signal into the future, that when we see Betelgeuse and we look at that star and we know when they're going to see the explosion, then they're going to send us a signal, and we can look at that star at the moment that we would expect them to have received that signal. And so people have proposed that these bright events that happen, they're shared viewing experience for various civilizations in the universe. That is the time to align your viewing habits to be able to see each other, and that you can just completely narrow down the search space. We only have to look at one system across a bunch of different wavelengths, but still only one system. And then the next system that will see the light of Betelgeuse is over there, and so we look at them. And then the next one's over there, and so we look at them. And we slowly look at each star system at the moment that they're going to be seeing the light from Betelgeuse go off, waiting for one of them to send us a signal. It's a pretty cool idea, and a way to kind of narrow down where to look for aliens. Ted Krause, wow, what a super harvest moon tonight. Is it a super moon? Yes. So today is a supermoon, which is a fairly new concept of the idea of a supermoon. So a supermoon is where, like, the moon is on an elliptical orbit around the sun. So it gets closer and, sorry, the moon is on an elliptical orbit around the Earth. And so at its closest point, it's about 380,000 kilometers away. And then at its farthest point, it's a little over 400,000 kilometers away. No, closest, it's 365,000. So at its closest point, it's about 365,000 kilometers away. And then at its farthest point, it's a little over 400,000 kilometers away. So from our perspective, the moon, when it's at the closest point in its orbit, it's much larger. And when it's at its farthest point in its orbit, it's much smaller. And so we can sort of see, and you can actually see animations of the moon as it is sort of, if you just stared at the moon would be looking like it's getting bigger and smaller because it is going around the Earth. But from our perspective, we're seeing it at different points in that orbit. And so then you match that up with the when the moon is new and when the moon is full. And when you get when the moon is at its closest point and it's also full, that's the supermoon. And it's, what is it? It's a syzygy apogee. No, it's a, yeah, syzygy apogee syzygy. Anyway, that's a supermoon. And then we've been trying to sort of have the opposite of this, which is when the moon is at the farthest point in its orbit and it's also a full moon. That's a mini moon. So just keep that in mind. You know, people always talk about the supermoon, but nobody talks about the mini moon. And like, is it actually brighter? Yes. It's about 30% brighter. So on the nights when the moon is very close and full moon, it is appreciably brighter than other points in its orbit. Now, obviously, the moon is the enemy of all astronomers, but it sure is cool. That's weird. Oh, we lost that fan. Okay. All right. Okay, I gotta do something here. Okay. So unfortunately, if Zapfan's gone, so the backup, unfortunately, Zapfan is no longer working. So I don't know if you're still classifying questions, but I'm not seeing any new questions in the database. So, okay. Arjone doesn't have the plugin. So it might be an early night. But anyway, KGS, why do space photography videos always come with that spiritual ambient music? It's funny. So although I hate it, I've been playing around with Sora 2 just to understand the technology, to understand the enemy. And so if I was having it generate space videos, and then I was also just browsing Sora 2 for space videos, and they're all this ambient spiritual music. And it's a funny thing, right? Like, why do they go together? I don't know. It's crazy. Thing on the shelf. Yeah. Let's do the thing on the shelf. Did I show you this? So this is the new thing on the shelf. So this is a Vespera 2 telescope, which is by Vaonis. And so this is kind of like a bigger, beefier version than the C-Star S50 that I've got behind me there. And so this was sent to me by Vaonis, and like I've been, people ask me to offer to send me telescopes, which I know, terrible problem to have. And so like I'm trying to remain independent, and so I bought the C-Star with my own money, and I use it. And so Vaonis reached out to me, and they said, oh, we've got a new telescope, the Vespera 2. We've got the version with the see-through plastics. You can actually see the internal elements of the telescope. I was like, fine. Yes. Okay. Send me the telescope. So they sent me this telescope. And unfortunately, it then rained for a week after I got the telescope. And now it's a full moon. So hopefully in the next couple of nights, the sky will be dark enough that I'll be able to take some pictures with it. So I have no idea how well it works. Yeah, it's pretty cool. Yeah, the C-Star, like, this thing is about $2,500 US, maybe it's 2,500 euros. And the C-Star is about 500 US. So right now, I'm recommending the C-Star all day, every day, as most people's go-to telescope to get used to doing astronomy with a small telescope. Like this idea of these automated telescopes, they take pictures and you get to see the images on your phone. It's totally revolutionary, and yet C-Star is the only one, or the Dwarf 3 has also made this relatively accessible. I've never tried the Dwarf 3, but the C-Star is a phenomenal telescope. And there's a bunch of issues that I have with I should take a picture of the moon. Although taking the picture of the moon during the full moon is sort of the worst time to take a picture of the moon. There's a couple of issues that I already have with this thing. It's kind of slow compared to the C-Star. Like the C-Star, you can just get it up and running a lot more quickly. And then the part that drives me crazy is that you have to connect to the Vespera with your phone, and the phone doesn't have so you have to connect to its own little Wi-Fi hotspot. And then your phone now, you can't be using it as a phone. It is now a standalone. Its only job is to connect to the telescope. With the C-Star, you turn the C-Star on, and then you connect it with your Wi-Fi once, and then you can put it into Wi-Fi mode, and then you teach it your Wi-Fi. And then every time you turn on the C-Star from this point on, it just connects to your Wi-Fi. And then you can control it through your Wi-Fi, but your phone is still a phone. You can still access the internet and do searches and use your various apps while you're using the telescope. So it's a much better way. And so I think it's surprising to me that Vaonis doesn't have that functionality as well. So, it now seems to kind of come down to the software. And the C-Star folks, they make the cameras. So they really know how to make astronomy cameras. And that's the heart of this whole process. So, so far, right now, and then Addicted to Globing is saying the C-Star supports equatorial mode. I don't think the Vespera supports equatorial mode, not that I saw. So you can put your C-Star onto a telescope mount that puts it at the angle of the Earth's tilt, and then instead of it doing the alt-azimuth where it sort of goes up and down and turns side to side, it will be following the tilt of the Earth. And so you can do much longer exposures with the C-Star, which is a lot better. So, and then, but I mean, it's a much better optics. Like if you look at the size of the telescope on this guy, right? The C-Star is maybe this long as a telescope, and the size of the aperture, I think this is a 70 millimeter. The C-Star is a 50. And when it comes to telescope aperture, right, like bigger is always better. So, okay. So I think I'm going to switch to, this is very weird for me, but I'm going to switch to reading the YouTube comments for a bit, and then we'll sort of see how long that goes. So I hate to do this. Mank Deems asks, do you miss the knowledge that the actual photons from the stars are entering your eyes rather than just from your phone? So if you buy a telescope, like, I always recommend the Dobsonian, that you will take your Dobsonian and you'll set it up and you'll point it at the moon and you'll be like, I cannot believe what's going on right now. I am looking through this telescope and I'm seeing the moon. I'm seeing craters. This is amazing. And then you'll watch night after night as the phase of the moon changes, and it's just like every night is this new adventure with the moon. It's incredible. And you look at Saturn and you can see the rings around Saturn, and you look at Jupiter and you can see the bands across the surface of Jupiter. If the telescope is strong enough, you can see the great red spot on Jupiter, and you can see Mars, and you can see the ice caps on Mars, and then you can make out the crescent shape of Venus, and then you can see Mercury as this little dot, and then you can see Uranus as this blue dot, and Neptune as this blue dot. And then if you live in light polluted skies, that's about all you can see. And then if you live in darker skies, then you can see some really cool star clusters. You can see some globular clusters. But the nebulae and the galaxies are the fainter objects. And through the eyepiece, they never look great. That at the very best, you're like, I can see a fuzzy, hazy blob in the telescope. And that is the Grand Orion Nebula, right? I can see this sort of hazy blob, and I know that's Andromeda, the Andromeda Galaxy. And yet, if you capture some photons, if you do a longer exposure, 10 minutes, or do a long exposure, 10 seconds, 15 seconds, 20 seconds, your eyeballs are throwing out their photons every few seconds. Do a long exposure, and suddenly you see all of the features, all of the details, all the stuff that you just can't see with your own eyes. So the question is not if you will eventually switch to doing astrophotography. It's really just a matter of when. That once you've looked at the planets and the moon, once you've looked at some of the brighter deep sky objects, you're out of targets, right? Like the universe is not putting more planets in front of us. So once you get a camera on your telescope, then you can look at 5,000 objects, 10,000 objects, weird nebulae, star clusters, and galaxies and in all different configurations. And so it's really a matter of like, if we could see those things with our eyes in telescopes, then people would never need to do astrophotography unless they were like really, they wanted to share the view with other people. But it's just that at a certain point, you do this long enough and a telescope just isn't good enough. And it's, and I think like when you look through a pair of binoculars at a bird and then you take a picture with a camera of a bird, it's kind of the same thing, right? That you saw the bird and then the camera took a picture of the bird and you show people. And yeah, like maybe you took a picture and the bird was doing something really interesting, flapping its wings or grabbing a fish or whatever, right? But you saw that with your eyes. It's not like that in astronomy, that what you see with your eyes is not what you can see once you take a picture. So really you do both. You get a small, inexpensive telescope that allows you to see the moon, the planets, some brighter deep sky objects, and then you switch to taking pictures, because that's the part where the hobby becomes the rabbit hole. Old timer, what movies and TV shows are you and your family watching at the moment? I actually just shared my big list of TV shows and movies. So what do we watch? We just watched 28 Years Later on our streaming service in Canada called Crave. And I was kind of disappointed, which was too bad, because every part of it should have been perfect for me. It was directed by Danny Boyle, who directed the original 28 Days Later. It was written by Alex Garland, who wrote the original 28 Days Later. And Alex Garland is probably my favorite director-writer. He did Ex Machina, he did Devs, he did Civil War. He's so good. And so it had Ralph Fiennes. It was weird and Danny Boyle-like, and yet it just didn't come together for me, and I just didn't enjoy it as much as I wanted to. So that was kind of disappointing. What else are we watching that's sort of sci-fi? We've just finished watching the last part of Alien Earth, and I put that in my top 10. I would say Alien Earth is probably one of the best science fiction television shows ever made. It's done by the guy who created Mutant X. Is that what it was called? But also Fargo. And so it's weird. It's weird, but it's good. And it's not what you expect. And it's not sort of the traditional story of what you would expect from an alien show. It's like set here on Earth, and it's about mega corporations battling over aliens and has children transferred into robotic bodies and robots having fights with cyborgs. And it's really weird and really good. So yeah, I think it was absolutely terrific. That's kind of all we're watching right now that's sci-fi related. Paige Potter, how do you decide which cosmic mysteries to treat with awe and which to treat with skepticism? I think so. For this, I probably have to follow Dr. Paul Sutter's answer for that, which is that if it's interesting, it's probably wrong. So a lot of the times when some kind of outlandish claim is made, my first instinct is to be skeptical about it. That, people were talking about, do you remember the Mach drive or the EM drive that came out a couple of years ago? Isn't it weird how that didn't go anywhere, right? Or when people thought that maybe neutrinos go faster than the speed of light, or room temperature superconductor, right? Like these are the big things that people are hoping for. And yet we have to be skeptical about them because, if it's interesting, it's probably wrong. That it's more likely that we're going to have the incremental progress, or the result of a big experiment. When we got the first images from the Event Horizon telescope, right? Like people had gone and built a telescope that was bigger than anyone had ever used before, literally turning planet Earth into a telescope. and then used it to take pictures of an event horizon around a black hole for the first time. And we saw the result, the shadow of the event horizon of the black hole for the first time. So when James Webb came online, then we saw new things that we had never seen before because the new powerful new telescope. When the LISA mission comes online, we will probably detect the mergers of supermassive black holes for the first time. So those I'm not as skeptical about, but when there are claims that are kind of amazing, my first instinct is to go, whoa, 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 whoa. Let's wait for more confirmation. Larry Williams, did the CME impact have any effect on 3I Atlas? So a thing that happened was there was a coronal mass ejection that was blasted off in the direction of 3I Atlas. And did it have any effect? I haven't heard of any paper that says that there was any effect, and there wouldn't really be a very big effect, when comets are hit by coronal mass ejections, unless they're very, very close to the sun. And 3I Atlas is very, very far away from the sun. It's like, it's out past the distance of Mars right now. People are talking about the three-body problem. Man, this sucks not having my database. People are talking about the three-body problem. So I've watched both the Chinese version as well as the Netflix version. And I've read the book. And I've watched the cartoon, the Chinese cartoon. So, so I think if I enjoyed the Netflix version of the three-body problem more than I enjoyed the 30 episode Chinese one, but the Chinese one was absolutely rigorously devoted to the original plot of the book. Like if you read the book and then you watch the show, they follow it beat by beat. But there was a couple of things that they did that were sort of, they made the boat scene, which if you've watched the show, you know what I'm talking about, that the people on the boat were mustache twirling, evil, bad people, while which was not what it was about, right? That it wasn't a justified action for the boat. The point of it was that it was awful. And so in the Netflix version, they handle it, I thought, a lot better. But it was just like tighter. There was a lot of cruft and a lot of extra stuff that was done in the Chinese version that the Netflix version sort of cut away. And in fact, they got a little bit into the dark forest with the Netflix version. So I'm looking forward to the next season, which will be great. It's one thing to do the first book, which is all set here on Earth and the 1970s in China. It's another thing to go forward into the future with all of the crazy nutty things that happen in the second book in the Dark Forest, right? Like that's going to be the challenge of the production team to be able to pull this off, because there's every part of it is advanced and it's in the future. And so the cities are going to be in the future, and the transportation is going to be in the future, and the way people are going to be dressed is in the future, and then everything's going to be technology, and there's space battles. So that is the question. Can they pull this off? So we'll see. Oh, is there like a fight going on in the chat right now? Zach Diecast Mansour, Fraser, are you excited about the movie Project Hail Mary? Yes, super excited about Project Hail Mary. So if you haven't already read it, that is another Andy Weir book, and very much in the vein of The Martian. Very lighthearted, chatty, but sort of a great adventure. He goes into the detail of all of the solutions, and there's a cool alien in it, which you meet in the trailer. So I'm not going to spoil anything if I talk about it a bit. And I'm really looking forward to Project Hail Mary. Okay, well, I'm going to wrap it up then, because I've had a technology fail, and so we need to solve this problem more permanently. So I think I'm going to wrap things up. So thank you, everybody, for hanging out with me tonight. Thanks in advance to Chad and Anton. Are going to have to manage this nonsense. Thanks to the mods who were here, and hopefully we will have this problem fixed so that we won't have this problem again. All right, thanks everyone, and I will see you next week.